So our next presenter comes from our National Institute for Research from Department of Environmental Sciences, and he's going to speak about mercury cycles in the environment and the methods to detect elemental mercury in the environment. Dr. Kotnik.
Okay, Damir, thank you for introduction. As he said, I'm coming from Jože Stefan Institute, Department of Environmental Sciences, where our basic research are how metals are cycling in the environment. Among other metals, a very important part is also environment. When we are speaking about mercury, we must be aware that it's all around us. It's in water or marine environments. We can find it in Arctic environments. We can find it in tropical forest, and especially in urban areas. Very polluted urban areas are usually quite elevated in mercury. Mercury have very good water solubility and volatility, and this is why it can be transported to very long distances, either by atmosphere, either by fresh water, oceans, or whatever. And because of that, we are treating it as a global pollutant. Mercury also has some very interesting properties. It's only metal which is liquid at room temperature. It also has very high density, and its elemental form, it's very volatile. With some other metal, it's form amalgams like gold, silver, aluminum, and its main oxidation state is mercury 2+. In nature, we can find it mainly as minerals, cinnabar, livingstonite, and it can also be found as elemental mercury. But it's not only anthropogenic. Mercury can be also of natural origin, and natural sources are evaporation from land and water, forest fires, some ores that are enriched by mercury, tectonic or seismic activity, and volcanic activity is the main natural source. The portion of naturally emitted mercury into the global atmosphere is quite high comparing to anthropogenic emissions, and it's about half-half. So half are natural emissions and half are anthropogenic emissions. And it is estimated that between 2,000 and 5,000 tons of mercury is emitted into the atmosphere yearly by natural sources. Mercury is also not evenly distributed on our planet. Mercury deposits are distributed as mercury belts. We have 3 mercury belts on our planet. We have Pacific mercury belt, Mediterranean and Asian mercury belt. And these belts are at the same place as tectonic boundaries. In the Mediterranean area, we have very intensive tectonic due to subduction of African tectonic plate under the European plate. Because of that, we have very strong seismic and volcanic activity in the Mediterranean and presence of mercury ores. In the Mediterranean, there are 3 most productive mercury mines in world history. One is One is Almaden in Spain, Mauta Miata in Italy, and Idria here in Slovenia. And what is interesting with Mediterranean is that on 1% of world surface, there is more than 60% of all world mercury deposits. So Mediterranean is naturally very enriched by mercury. And when mercury comes to the environment, it is not still. The problem with mercury is that when we are releasing it into the environment, it starts to cycle. In the atmosphere, it can be oxidated to mercury 2+, it can be deposited by rain or by dry deposition. It can be transported to long distances. And when it comes to water environment, it can be methylated and demethylated to more toxic form of mercury, dimethyl mercury and methyl mercury. Methyl mercury is mainly produced by microorganisms in the water environment, either in water column or in the sediment. Mercury can be also oxidated and reduced, which means that it changes its electronic state, its gaseous or aqueous form, and when it enters into the food chain, it can be bioaccumulated and biomagnificated. And at the end of food chain, usually there are humans. Now I will just show you a few cases for different mercury species in waters of the Mediterranean Sea. Here in the north of Adriatic Sea, we have strong pollution from mercury mining in Idria. There is also some industry, mostly on Italian side, and we can see some elevated places like near Aeolian Islands, where we have intensive tectonic activity and volcanic activity, which cause elevated levels of total mercury. It's same for dissolved gaseous mercury. This is mercury which is in elemental form and in gaseous form in waters. It's basically same. On the northern part of Adriatic, cause of pollution is mercury mine, industry, and in the Mediterranean, somewhere in this part, the elevated concentrations are caused by tectonic activity. And this is not the case with methyl mercury. Methyl mercury is produced in the middle of the Adriatic Sea. This is the part of Adriatic Sea which is the deepest, and it has the strongest microorganism activity. So mercury is here methylated. It goes out of the Adriatic Sea, enters into the Mediterranean, and in the Mediterranean we can see elevated concentrations of methyl mercury. And just to take a look, mass balance in the Adriatic Sea, how much mercury is coming in, coming out. That blue numbers are for total mercury, red numbers are for methyl mercury. And we can see that evasion from the sea is quite high comparing to inflow from rivers or diffusion from sediment or even outflow to the Mediterranean. And in Mediterranean, situation is pretty much same. We can see that evasion and deposition, evasion from the sea and deposition are main source or sink of mercury. Fish harvesting, it's about 300 kilos per year of total mercury and 290 kilos per year of methyl mercury. And why this is the problem? The problem is that in Mediterranean Sea, we have either in sardina fish or in tuna fish, we have elevated concentrations of mercury in that fish, which becomes economical problem, not only health problem, but also economical problem. And if we look on concentrations, here in the water concentrations are quite low, and then they are rising on different food chain level. The highest levels we have in tuna fish, which is predator fish, lowest are in sardines, and so on. And the percentage of methyl mercury comparing to total mercury, it can be in sardine or tuna fish over 90%. And the methyl mercury, as I said, it's more toxic form than elemental mercury. Human activity change mercury cycle since pre-industrial era quite a lot. If you take a look on that numbers, how much was natural evaporation or evasion comparing to what we have today. So numbers are several times higher now. And this is only because of anthropogenic influences on mercury cycle. If you compare natural sources of mercury to anthropogenic sources, you can see that it's about half-half. Half natural and half anthropogenic sources. Among natural sources, biggest source are volcanoes, then there is volatilization of mercury from soil or some contaminated areas from geothermal areas. Anthropogenic sources are mostly fossil fuel burning for power or heating, metal production, gold mining is quite high emitter of mercury, and dental amalgam fillings. This is 1%. But in this 1%, there are counted only dead people that are cremated. All living people with amalgam fillings are not counted into that number, and I'm sure that this number is few times higher. Emissions of mercury, how they are distributed on the globe. We have highest emission in Asia, like China, India, and there here in South America, Africa, you can see hotspots in emissions. And these hotspots are mainly due to gold mining. Artisanal gold mining, these are small mines, and this gold mining, it looks like in all Western movies. Panning of gold sand, and then this gold sand is mixed with mercury to amalgamate. Mercury sand will stay. They got amalgam which have about 60% of gold and 40% of mercury, and then that mercury is evaporated out and only gold is staying. In such environment, concentrations can be quite high or really very high. I will show you later how these concentrations are going. And here are findings from ice cores. They got ice cores in Alaska, in the United States. Here you have concentrations of total mercury in nanograms per liter in melted ice water, and they dated that. And we can see that in pre-industrial times, concentrations were quite low. There are some peaks like Tambora volcano eruption, Krakatoa eruption, and you can see there is gold rush in the United States when they were panning gold in Alaska or California. And then in industrial era, we have increase of that mercury in that ice water. We can still see some peaks from volcanoes, but this peak is mainly caused by human activity. And how mercury looks in Slovenia? Slovenia is quite enriched in mercury. We had 4 mercury mines in the past: Podljubelj, Črna pri Kamniku, and Marija Reka. There are small mines, but presence of mercury is still there. The main mine was in Idrija, and as Dr. Kubal showed it before, it's mine with 500 years of mining and ore smelting history. In 1994, all mining and smelting activity stopped. Mercury in ore was up to 10%. Mostly there was cinnabar and about 30% of elemental mercury. There were 12 million tons of ore that was excavated, and about 100,000 tons of mercury was extracted. But what was problem here is that 44,000 tons of mercury which were lost into the environment during mercury production in that mine. And what happened there? I have some model here. Still now, about 1 ton of mercury is eroded into the Idrica River, which is flowing through the valley. From that amount, nearly 900 kilos of mercury is going from Idrija area downflow by Idrica River. And what is problem here? That pollution in Idrija not influences only Idrija and its surrounding. It influences also Idrica River, Soča River, and finally it flows into the Gulf of Trieste, where it causes the main problem. There are still overbanks with flood deposits which contains really a lot of mercury. When on Soča River there are 4 dams, and when river with mercury came into behind the dam, it started to cycle. We will have methylation, we will have reduction, oxidation, we will have bioaccumulation, and after that dam it entered the Gulf of Trieste. And in the Gulf of Trieste we will have same reactions as behind them, and we can see here from Idrija it's going about 900 kilos of mercury each year. Into the Gulf of Trieste there is coming about 1.5 tons of mercury. Some mercury is going out of the bay, some is coming in, but most mercury is settled in the bay. And in the Gulf of Trieste, the problem is with fish farming, shell farming, and so on. Since beginning of operation of Mercury mine, about 2,000 tons of mercury enters the Gulf of Trieste, and most of that mercury remains there. Well, mercury is toxic metal, but it has some nice properties that we are still using it. Now we can find it in compact fluorescent lights. These are that lights that we are using now. Each of that bulb contain about 2 to 5 milligrams of mercury. And when they are new, they are mostly, the mercury here is mostly in elemental form. With use, it will be bounded to phosphor, which is on glass. Then we still use mercury UV lights, we use dental amalgams, we still use thermometers, mercury is in some mercury switches, relays in manometers. A lot of mercury is used for gold extraction. We use in cosmetics, medicine. Mercury fulminate is still in use in explosive detonators. It can be found also in some old batteries, and so on. Concentrations of mercury that are in air. In unpolluted air, concentration would be around 1 nanogram per cubic meter. So 1 nanogram is unpolluted. In towns like Ljubljana, air would have some 4 to 5 nanograms per cubic meter. In Idrija, where the mine is located, now it is up to 10 nanograms, and this is treated as a polluted area. In some non-aerated room where a lot of people are, and if people have dental amalgams, concentrations would rise up to 20 nanometers. If we broke mercury thermometer in room, it would increase up to 3,000. And in dental office, where they are using dental amalgams, concentration will be comparable to a room where somebody broke mercury thermometer, and that mercury droplets are still somewhere in the floor. In dental office, when you remove dental amalgam, concentration can be about 10,000 nanograms per cubic meter, which is very comparable to Idrija mercury mine today. Underground, there are no operations anymore, but we have elemental mercury there, and concentrations are still quite high. They are not as high as they were during operation of mine. Well, it's not so much that in some really polluted environments, like surrounded of mercury smeltery in China or other parts of the world. But however, these concentrations are still 10,000 times higher than concentration in unpolluted air. And when we are speaking about mercury in environment, we must be aware that in the environment there are different species of mercury. Total mercury, methyl mercury, elemental mercury. It can be bounded to particulate matter, it can be dissolved in water or whatever. And usually in non-polluted environment, it is at very low concentrations, it can be like few picograms. It's same with biological samples and industrial samples, but biological samples and industrial samples have usually a little bit more mercury. Mercury also have stable isotopes, and to measure all that in nature, we need some methods that are able to do this. Basically, when we are measuring mercury, we are mostly using amalgamation properties of mercury, because mercury will amalgamate on gold troughs, because we need to concentrate it, because in the environment it's in so low levels. And then we can use different techniques like cold vapor atomic fluorescence spectrometry, cold vapor atomic absorption spectrometry. We can use inductively coupled plasma mass spectrometry. We have a lot of other methods. We use also nuclear methods. And here I will stop. I hope that I will show you a little bit how mercury is behave in nature, and that problem of mercury is not only that it is toxic to human, it also causes environmental damage. Thank you.